Hello guys, today we're going to be talking about how to name inorganic compounds. But before we begin, we need to learn a little bit about the periodic table in order for us to properly name uh, those inorganic compounds that we will encounter. Um, One thing you can notice right away from this periodic table is that there's three shades. There's this white shade here, green shade here, and then this purple. The white shade represents all the metal atoms. The green shade represents all the non-metal atoms, and the purple represents all the metalloids. We'll come back to this. Um, Another thing we need to know is that the boxes that go down vertically, we call these groups. So they're actually numbered here on top. Group 1, 2, A. These are A under A, and these are under B, 3B, 4B. Here, 13A, or we say 3A, continue from here. After 2A, there's 3A, 4A, 5A, 6A, 7A, and so on. The boxes that go horizontal, so all these horizontally, we call these periods. So this is period 1, includes hydrogen, helium. Period 2, starting with lithium and on. Period 3, lithium, magnesium, and so on and so forth. Um, some characteristics of these three is that metals are solid and they have high heat and electric conductivity at room temperature and sea level. Also, at same conditions, the nonmetals can exist as solids, liquids, or gases. And then metalloids, they are in between, so they can share characteristics of either this metal or non-metal. So that's why they're in between here. All the purple ones here. All right. Also, we need to know some chargers when it comes to atoms in order to name them properly. Uh, Remember just that group 1, starting from lithium here, not excluding this hydrogen. Group starting from lithium, going all the way down. We call these alkali metals. So just remember these are mostly +1 charge. So +1 charge. Group 2 here, starting with beryllium. We call these alkali earth metals, and these are going down all the way. These are all mostly in, they have +2 charges in ion form. And I mean, ions are atoms who have lost or gained electrons. Um, let's move on to here, group 8. All the group 8 atoms here are called noble gases. And noble gases have no charge. Here, this group 7A, we call them halogens. I'm missing an A right here. Halogens have -1 charge. So just remember that from fluorine all the way to AT atom. So -1 charge. And 6A has -2 charge. -2 charge from oxygen all the way down to this atom right here, Te. And nitrogen and phosphorus, just remember these are mostly negative -3 charge. Um, Also, one of the metals that we can assign a charge um, is this aluminum metal. And remember that just remember aluminum is +3 charge. All these metals here, starting here and going all the way down to here, from 3A all the way to 12B, these are what we call transition metals. All right, we can move on now. Here, I have an example of inorganic compound that is made by sodium ion and a chlorine ion. Uh, this is a +1 charge because it's in a group 1. here, and chlorine is in group 7A or 17A, and it's -1. So naturally, these two guys attract one another because one is positive, the other is negative, and they make up this compound. To show this a little more intuitively, this is on the left. This what happens. So chlorine gains an electron. It comes initially from the sodium here, and then the sodium here loses this electron, which chlorine gains and becomes positive charge. Negative charge ions, we call them anions, and positive charge ions, we call them cations. So, so what is an ionic compound? Ionic compound is pretty much made up of cations and anions. To begin naming, let's start with naming cations. How do we name these guys here? To begin with sodium, we call this a sodium ion. We call this guy a lithium uh, ion. Notice I have ion at the end of the word because these are have these guys have these two guys have lost a electron, so they become an ion. And this is a aluminum ion. Uh, Remember those transition metals in the middle? These guys. Let me show you. The reason we didn't predict none of their charges here in the bottom, all these guys, is because their charges usually vary. And here are some atoms with the same atoms with different charges. So for example, here's the iron with a +2, and here's the iron with a +3 charge. And so how do we name these guys? So here, iron 2, iron 3. So notice that I have actually marked these two irons with the Roman numerals right next to them, specifying their charges. Let me not forget ion here and ion here. Here we have a copper atom, and here copper has +1 charge, and here has +2 charge. Like the iron, we use Roman numerals again, so copper 1 Roman numeral, whoops, ion, and copper 2 Roman numeral ion. So not only metals or transition metals can become cations. There are some nonmetals also that can create nonmetal cations. For example, the way we name nonmetals that make cations, their name ends in IUM. So, for example, here we have a, a molecule called ammonium ion. And this is notice the last three letters, IUM, and this is a hydronium ion. Again, IUM at the end. So, since we talked about cations, now let's talk about anions. So, here it says monatomic anions, and then IDE. So, monatomic pretty much means that ion made up of one one type of atom or one atom. So mono means one atomic atom, one atom. And these and their names end in IDE. So here we have a hydrogen. So then the way we name hydrogen ion, uh, we call it hydride ion. So hydride ion. Here we have a nitrogen ion, and we name this like this: nitride. Sorry about the handwriting. Nitride ion. Here we have oxygen ion, and we call this oxide. Oops, oxide ion. Notice that we do not show the charge numbers with Roman numerals. We only do that with those transition metals. Here we have polyatomic anions. So poly means multiple different atoms or multiple atoms. Here we have oxygen, hydrogen. The way we name this molecule also the name ends in IDE here. Just notice that. So this is a hydroxide ion. This is a carbon and nitrogen making up this molecule. We call this a cyanide ion. Here we have a oxygen, two molecules of oxygen making, two atoms of oxygen making this molecule, and this we call a peroxide ion. So oxygen containing polyatomic anions called oxyanions. So here we have a molecule, a couple, 1, 2, 3, 4 molecules, and notice that their number of oxygens are different. Same nitrogen with a different number of oxygens. Here we have sulfur with oxygen, different number of oxygens. And the common name for this one is nitrate ion. Nitrate ion. And the bottom one, so whenever, so you take a common name and then whenever there's a oxygen subtracted, one oxygen subtracted, you put a ITE at the end. You take off the ATE and you put ITE. So this one is called nitrite ion. This is a sulfur oxygen, 4 oxygen molecule, and a common name for this molecule is sulfate ion.